Table below represents the distance in meters required by a car to apply brakes and reach and stand still when it is traveling at a given speed. And then we think it makes sense to say which the higher the speed, the more distance it will take to stop. So that's what we are predicting. Okay, let's check. So we have 20, which goes with 6. So we have 20. So this is 4, 8, 12, 16, 20. 20 goes with 16. 6, yeah, here is 6. Okay, 40 goes with? It goes with 16. 4, 8, 12, 16. It's 40, it's 4, 8, 12, 16. Okay. And then 60 goes with? Okay, next. Is what? 80 and 48. Okay, 80 and then it's 40. 48. This is 40. Okay? 42. Yeah, it's here. Okay, next, what do we have? 100 goes with 70. Okay, 120. Okay, 140. 110. And then you can clearly see which it gives us, you saw the difference. Again, the one of an exponential, it started here. Can you see that again? And then it went something like this. It was more of a curve. But this one here, it doesn't even touch this part here. And then it's linear. If you can check this thing here, it's following a straight line trend. So the next question that they asked us here was, explain whether it's linear, quadratic, or exponential. So we said it's what? It's linear. And then if it's linear, then we're going to be starting to talk about something which is called a line of best fit or the regression line. So as soon as it becomes linear, the next thing that we're going to be talking about is that we're going to be talking about a line of best fit. If they don't want to call it a line of best fit, they're going to call it a regression line.